Find the maximum area of an isosceles triangle inscribed in an ellipse x square by a square plus y square by b square equal to 1 with one vertex at one end of the major axis. So here we are talking about an isosceles triangle. An isosceles triangle is going to be inscribed in an ellipse. So let's do one thing. Let us draw an ellipse x square by a square plus y square by b square equal to 1. In this ellipse, let us draw the isosceles triangle. Now in this isosceles triangle, take one vertex at the end of the major axis, that is A, which is minus a comma 0. So this is one vertex of the triangle, the others is B and C. So this is the triangle in question. Triangle ABC, we want to maximize the area of this triangle. Triangle ABC, A is a fixed point, minus a comma 0. Now B and C are two variable points. The trick here is to take B in a certain format. We want to find the area of the triangle ABC. So let us see what is the first part of the question. I am going to take B as A cos theta, B sin theta, where theta is this angle. Now this is a trick in which you have to take it, guys. Remember, B is A cos theta, B sin theta, and C is A cos theta and minus B sin theta. A cos theta and what? Minus B sin theta, because the B sin theta comes on the down part, that's why it is negative. Now I want you to write area of triangle ABC in terms of one single variable. How to write the area of triangle ABC in terms of one single variable theta, for which we are going to use now half into base into height. So let's see, area of the triangle is half into base. Now look at the triangle from this perspective. Let me draw the eye for you. So look at the triangle from this way. Yes. So half into base. What is a base? BC. What is a height? AD. So half into base into height. Now we need to write this in terms of single variable theta. A and B are constants. A and B are constants. So how do you write B? First let's talk about BC. Now BC, BD will be A B sin theta. Now think why BD will be B sin theta. Let me show it in red color. So the length BD, which will be the y coordinate of B. What is the y coordinate of B? It is B sin. Now similarly, we get OA as A. The length OA is A. The length AD is A cos theta. It is the x coordinate of B. So the total length is going to be A plus A cos theta. So what will be the length AD? It will be A plus A cos theta. So that means the length AD is A plus A cos theta. So what is the area of the triangle? Area AC, area AD is A plus A cos theta. I have no idea why this is little shivering like this. Okay, so you have area of the triangle will be, area of triangle ABC will be half into bracket 2B sin theta, half into base into A plus A cos theta. Now what you're going to do is you're going to take A common out, cancel the 2 and 2, take A common out, cancel the 2 and 2. So you get area of the triangle will be AB bracket sin theta plus sin theta times cos theta. Sin theta times cos theta. Now you are going to take dA by d theta and equate it to 0. But before taking dA by d theta, it's a good idea to simplify this expression. Why? Because we want to avoid the product rule. Now how to find dA by d theta and equate it to 0? So A is equal to AB sin theta. Write down. A is equal to AB sine theta plus multiply up and down with 2. So you get 2 sine theta cos theta upon 2. Now why did we multiply up and down with 2? So that we get sine 2 theta. So you get AB into bracket sine theta plus half into sine 2 theta. So we have compressed it to a single function so that we don't need to use the product rule. We can just use the direct derivative chain rule, that is AB into sine will become cos theta plus half into 2 cos 2 theta. Now the 2 and 2 will cancel, and now we need to solve this equation. Cos theta plus cos 2 theta is equal to 0. How do you solve cos theta plus cos 2 theta equal to 0? We are going to use cos C plus cos D formula. Now let us use that formula, cos C plus cos D. So find theta by putting dA by d theta equal to 0. To put dA by d theta equal to 0, you get AB into cos 2 theta. We have already found that. Now use cos C plus cos D. So you will get 2 cos C plus D by 2. So 2 cos 2 theta plus theta by 2 into cos 2 theta minus theta by 2 equal to 0. Now let me remind you that cos of pi by 2 is 0. So one of these angles has to be pi by 2. So take 3 theta by 2 as pi by 2 or theta by 2 as pi by 2. Theta by 2 as pi by 2. Not cos theta by 2, only theta by 2. So that means there are two possible answers. One is theta can either be pi by 3 by cancelling the 2 and 2, or theta can be equal to pi. Now theta cannot be pi, so we reject it because theta is this angle. If theta is pi, then that point will go to the other side. Theta cannot be 180. Hence the correct angle is theta. So theta is equal to pi is rejected, and theta is equal to pi by 3 is the accepted angle. Now once you get theta as pi by 3, what do? We substituted that theta is equal to pi by 3 and actually find A max, the maximum area. Now two more things to be done. Now before that, how did we get this? We used cos C plus cos D, which I am writing the formula in case you have forgotten last year's formula, and then we put cos pi by 2, one of them as cos pi by 2 because cos 90 is 0. Now the fourth part is to find the maximum area. How to find the maximum area? To find the maximum area, substitute theta is equal to pi by 3 in the area equation. So A max is, substitute AB into bracket. Now if you recollect, it was sine theta plus sine 2 theta, half sine 2 theta. So sine theta would be sine pi by 3, sine pi by 3 plus half into sine 2 pi by 3. So take AB common. What is sine pi by 3? Plus half into sine 2 pi by 3. Now sine pi by 3 is sine 60 root 3 by 2, and sine 120, that is also root 3 by 2, because sine 120 is sine of 180 minus 60. So now take root 3 by 2 common outside, and you will get the answer as root 3 AB upon 4 you should get, not 2. I will make the correction later. It is upon 4. Do the calculation yourself. Take AB, take root 3 by 2 outside, 1 plus half. 1 plus half is 3 by 2. So 3 root 3 by 4 AB, that is the maximum area. Now all we need to do is take the second derivative and show that the second derivative is a negative quantity, because only if the second derivative is a negative quantity, this is maximum. So we already got the maximum value, we just need to prove that it is actually the maximum value. So what we do now? We go to the second derivative. So let's write the formula for the first derivative first. dA by d theta. So dA by d theta, now d2a by d theta square is AB. Prove that d2a by d theta square is less than 0. So AB is outside. So minus sine 2 theta, minus 2 sine 2 theta, minus cos, minus sine theta again. Now we need to substitute minus AB, so you'll get minus goes out, a 2 is there, of course, I forgot the 2 part. So sine, whatever it is, there is a minus sign out, so it's clearly a negative quantity. So it's clearly a negative quantity, so the 2 is not there actually, actually there will be a 2 sine 120, but it really doesn't matter as long as it is less than 0. We have proved that it is a maximum. So the maximum area is 3 root 3 upon 4 AB. Let's quickly go over what we did. We had to maximize the area of the isosceles triangle. So the isosceles triangle is placed inside the ellipse. So remember, we take the coordinates of B as A cos theta, B sin theta. This is actually called the parametric form of the ellipse. A cos theta, B sin theta. So any point in the ellipse you want to take as x comma y. Instead of that, we take A cos theta, B sin theta. That's why we took a B as A cos theta, B sin theta. But since C is direct below it, we take the x coordinate will be the same, but the y coordinate will be minus B sin theta. So using this technique, we could write the area of the triangle in terms of one single variable, which is AB sin theta plus sin theta cos theta. Now sin theta cos theta we compressed because we didn't want to use the product rule, so we multiply and divide it with half and compressed sin theta cos theta as half sin 2 theta. Once you have half sin 2 theta, then we used dA by d theta and we equated it to 0. Check it out, dA by d theta equated to 0 and we rejected the value of pi. So how did we find that? We used cos C plus cos D formula. And remember, cos of 90 is 0. Since cos of 90 is 0, one of these quantities has to be 0. So either 3 theta by 2 is pi by 2 or theta by 2 is pi by 2. But theta is equal to pi is not possible from the diagram, hence that got rejected, and that's how we took theta is equal to pi by 3. Now once theta is equal to pi by 3 we got, what did we do with that? We substituted it back and we got the maximum area as 3 root 3 AB upon 4. Check it out. 3 root 3 AB upon 4. We substituted theta as pi by 3. Remember, sine of 60 is root 3 by 2. And sine of 120. What is sine of 120? Sine of 180 minus 60. That is also root 3 by 2. Hence, we got half into root 3 by 2. Taking root 3 by 2 common, 1 plus half becomes 3 by 2. 3 root 3 by 4 AB. That is the maximum area. And then finally, we had to just prove that it is indeed the maximum by applying the second derivative test. Actually, I recorded this 3 times, guys, but the audio did not go through. I'm really tired actually talking the same thing. This is the 3rd time I'm recording it actually. Anyway, I hope you understood it. Little tired now. So we took the second derivative and what did we prove? We proved that the second derivative is less than 0. First time when I did it in Show Me, the audio did not work. Second time I tried to do with another audio. I put it again and it still did not work. Now this is the 3rd time I'm doing and we got theta as pi by 3, sine 120, we missed the 2, sorry about it. But anyway, the minus sign only matters. It is less than 0 and that's how we proved that it is less than 0. So that means since the second derivative is less than 0, the area is maximum. I hope you understood it, guys. If you have any question, just let me know. next class when we are meeting. Thank you for watching. Goodbye and take care.